Hello. In this video, we're going to look at a different type of transformation. What do you think y equals 3 f of x means? Now, there's a 3 and an f of x, and whenever a number and a letter are touching, we assume it means multiplication in math. So a first guess might be, oh, okay, well 3 times f of x. We're going to multiply f of x by 3. But what gets multiplied by 3? I mean, we have, for example, over here, a point at 2 and 1. Does 3 f of x mean 2 times 3, which is 6? Does it mean 1 times 3, which is 3? Do they both get multiplied? What's going on here? And so we need to kind of understand this 3 f of x. And so what we're actually going to do is we're going to go ahead and type it in on Desmos and see if we can understand, because Desmos understands this language. This is an equation that Desmos will comprehend. And let's see if we can reverse engineer what it would mean in English to us. All right, so here we have our initial function. We can see this sort of W shape here. And we have y equals 3 f of x. So let's go ahead and turn that on and take a look. Well, we can see here that the point we are looking at, 2 and 1, has now moved up to what appears to be 2 and 3. Okay. The point here at 0 and 1 appears to have moved up to 0 and 3. And interestingly, this point here at 1, 0 seems to remain at 1, 0. So if we zoom out, I think we can see that this W is 3 times bigger, quote unquote, than the original W. But I think it's only bigger in one direction. And hopefully you can see now that not both values are getting multiplied by 3. In fact, only the second value, the y value, is what's getting bigger. The word we would use here is a stretch. And so those y values have been stretched. They've been, instead of at 1, it's at 3. We can kind of animate this here with a bit of a slider. So if we go and we stretch it from 1 to 3, we can see how the initial shape gets stretched out and made to be a lot bigger, a lot taller, if you will. And so this here, we would describe in English as a vertical, because it's the y values. It's a vertical stretch by a factor of 3. The y values, or the vertical values, have been multiplied or stretched by 3. So let's go ahead and do this ourselves. How would we calculate this? Well, we would take our initial values, we'll maybe grab these 5 here, and put them in a table. So we have x and fx. X is minus 2, minus 1, 0, 1, and 2. And the y values are 1, 0, 1, 0, 1. Now we're going to create a new table, x and y if you want. And what's happening is these values are going to get multiplied by 3. But the x values stay just where they are. So minus 2, minus 1, 0, 1, 2. This becomes 3, because 1 times 3 is 3. 0 times 3 is 0, 3, 0, 3. And then we would simply plot those points either on a new graph, or I think we can actually fit it here on the same graph. So negative 2 and 3, negative 1 and 0, 0 and 3, boom, boom. And so we have this beautiful new graph. And again, the way we'd write this in English is we have been stretched by a factor of 3, and we include the word vertical. So vertical stretch, or vertically stretched. Yeah, let me just fix the English here. Vertical stretch by a factor of 3. That's how we write the y equals 3f of x in English. Now, what do you think y equals f of 2x means? Well, I mean, just kind of using some logic here, if the 3 outside meant multiply the y values by 3, the 2 inside would mean multiply the x values by 2. So let's go ahead and take a look at Desmos, and we'll just confirm our hypothesis. All right, so here we have our function again. And we turn on the graph of y equals f of 2x, and we expect the x values to be multiplied by 2 and the y values to remain the same. Well, let's look at this point here. This was the point 1 and 0. So we'd expect the new point to be at 2 and 0 over here, but wait a minute. It's over at 0.5 and 0. That's kind of weird. And the point over here at 2 and 1, that point seems to be at 1 and 1. It almost looks like the graph, instead of getting 2 times bigger, it looks like it's gotten 2 times smaller, or like half as big. It doesn't look like the graph has been stretched out. It looks like it's been shrunk down. This is a little weird, but I think if we look here, the number 1 would go to 0.5 if we divided by 2. The number 2 would go to 1 if we divided by 2. And here this point was at 0, so 0 divided by 2 would just be 0. So I think what's happening is the 2 inside here is not multiplying by 2. It's actually dividing by 2. But that should kind of make sense, because if you remember from the x values, if it was a plus x, we had to do, like x plus 2, we would have to do x subtract 2, because we have to do the opposite inside the brackets. So here, if it's a 2 times x, we have to divide by 2. So I think that makes sense. The opposite things apply when we're looking inside the brackets. So again, let's go ahead and do it by hand. So we have our graph here, and we grab our initial table. -2, -1, 0, 1, and 2. And then the y values of 1, 0, 1, 0, 1. And now when we go to make our new table, these values here are going to be divided by 2. So -2 divided by 2 is -1. This is -1/2, 0, 1/2, and 1. But the y values remain unchanged. All right, so let's go ahead and plot that here. We'd have -1 and 1. Oh, sorry, -1 and 1. -1/2 and 0. 0 and 1. 1/2, 1. Then we connect up the dots. And we see that we have a W shape, right? It's the same graph in the sense of we haven't moved it or created some wildly new shape. But we have taken the graph and we have made it smaller this way. We've done a stretch, but it's been a stretch by a fraction. So the way we would write this in English is we have done a horizontal stretch by a factor of 1/2. So the key here is that if it's a 2x, that actually gives you a 1/2. Either you can think of it as dividing by 2, or if you want to keep everything with multiplication, which I do think is a bit of a better approach, instead of writing divide by 2, we can flip it around. And so we say we multiply by 1/2. So the 2x becomes a multiply by 1/2. It's to the x values, so that's why we call it horizontal. And so in English, we'd say it's a horizontal stretch by a factor of 1/2. All right, so let's give this a try. I want you to pause the video and graph y equals 4f1/5 x. So here's the initial graph, and we have both transformations. We have the vertical and we have the horizontal. Right? The 4 means we're going to multiply the y values by 4. The 1/5 means we're going to multiply the x values by the reciprocal of 1/5, which I think means multiply by 5. But I don't want to give too much away. Pause the video and see what you come up with. All right, assuming you gave that a try, let's grab our initial values. So we have -2, -1, 0, 1, and 2. And we have 1, 0, 1, 0, 1. So these are going to become the x values here, we're going to multiply by 5 because we do the opposite. The opposite of 1/5 is 5/1. And here the y values get multiplied by 4. Okay, so -10, -5, 0, 5, and 10. 4, 0, 4, 0, 4. All right, let's go ahead and take those values. I don't think they fit on this graph, so we're going to make a new graph just below, and we'll plot the points. All right, so we start over at -10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So -10 and 1, 2, 3, 4. Maybe a little bit higher there. Then we go down to minus 5. 1, 2, 3, 4, 5. Minus 5 and 0. Then 0 and 4. 1, 2, 3, 4, 5. 6, 7, 8, 9, 10. Something like that. And then we connect the dots. And there's our new graph. Again, if we were to write this in English, we would say vertical stretch by a factor of 4, horizontal stretch by a factor of 5. Let's go ahead and take some notes on this. So here we are learning about stretches, both vertical and horizontal. And so if you have y equals a, f, b, x, a means you multiply y values by a, and the b means you multiply the x values by 1 over b. So as an example over here, let's say you had y equals 3, let's do a different number, 4 f of, let's do something tricky. Let's do 2/3 x. What would this mean if we had a little table? So what I'll do is I'll give you a table. This will be given. This is your given table. So I'll give you -2, -1, 0, 1, 2. And then I'll give you 1, 2, 4, 7, 0. Just some random numbers. And your goal is to figure out the new table. All right, go ahead and pause the video and give that a try. All right, so what we have to do is multiply the y values by 4 here. So let's do that first. That'll become 1 times 4 is 4. I'll write that here. 1 times 4 is 4. 2 times 4 is 8. 4 times 4 is 16. 7 times 4 is 28. 0 times 4 is 0. Okay, the x values are a little trickier. We have to here, for the x, we have to multiply by 3 over 2. Ooh, okay, so -2 times 3 over 2 is -3. So it'd be -3 over 2, 0, 3 over 2, and 3. A little tricky with the fractions there. Again, the reason why we do 3 over 2 is because we take this and we do the opposite, so we have to flip it. So for some practice, you can try worksheet 7 and 7.5, and you can add an example here to your notes. And then any things to remember. The main thing is that because they're touching, it becomes multiplication, and because it's in the brackets, we have to do the opposite for the x. Or you might want to write down a thing to remember is the English phrase, vertical stretch by a factor of 4. We need to have that phrase written properly. We can't just say like, stretch it by 4. We have to say the specific phrase, just like we would say a vertical translation, 3 units up. We want to make sure we're communicating with precision. So whether we're going to write the transformation equation or we're going to state it in English, we want to make sure that we're being precise with how we're speaking about these transformations. All right, hopefully you enjoyed this video. And as always, thanks for watching.